This question gives us x cubed plus 15 is less than or equal to 3x squared plus 13x. I would like to put everything on the left side. So I'm going to subtract 3x squared from both sides. I'm going to subtract 13x from both sides. If I subtract 3x squared, I do not change the sign. If I subtract 13x, I do not change the sign. If you multiply or divide by a negative, you've got to change the sign. Let's write this in an order that we can use. So x cubed minus 3x squared minus 13x plus 15 is less than or equal to 0. So I want to solve this, but first I'm going to solve the equation. So the corresponding equation would be x cubed minus 3x squared minus 13x plus 15 equals 0. And how are we going to solve this? Well, you know, we can go through our various synthetic division kinds of strategies. Factors of 15 are 1 and 15 are 3 and 5. Factors of 1 are just 1. And again, all of these are plus or minus. So I really only have 8 different things I've got to try, right? Plus and minus 1, plus and minus 3, plus and minus 5, plus and minus 15. Those are potential rational roots. If I find 1, then I can get the other 2 using a different kind of strategy, using quadratic formula or factoring or completing the square. So let's go ahead and play the synthetic division game. We'll try 1 first. 1, negative 3. Negative 13, 15. See if that works. 1 times 1 is 1, negative 3 and 1 is negative 2. 1 times negative 2 is negative 2. Negative 13 and negative 2 is negative 15. 1 times negative 15 is negative 15. Add those together, we get 0. So indeed, 1 is a solution. So 1 is a 0. 1 is a solution. I will circle that. What I have left now is 1, negative 2, negative 15. Which is the same thing as 1x squared minus 2x minus 15. I want that equal to 0. That's probably easily solved using factoring. Oops. Okay, strange box, but it'll work. X squared here, negative 15 here. The middle terms have to add up to negative 2x. So x times x, negative 5 and positive 3 gives me negative 5x, and positive 3x adds up to negative 2x. So x minus 5x plus 3. So this becomes x minus 5 times x plus 3 equals 0. So x minus 5 is 0, or x plus 3 is 0. So x is 5 or x is negative 3. Those are the other zeros of this that we're working for. So let's collect all of our information. We have our original question that we had. Was x cubed plus 15 less equal 3x squared plus 13x. And then we rewrote it by subtracting 3x squared and 13x from both sides, and it became x cubed minus 3x squared minus 13x plus 15 is less than, plus 15 is less than or equal to 0. I solved it as an equal. When I solved it as an equal, my answers were 1, 5, and negative 3. The solution set here was x is 1, x is 5, x is negative 3. So let's lay out a number line. The first one in that list would be negative 3. Then 1, then 5. You'll notice it's less than or equal to, so all of these dots are solid. All of these dots are solid. I have got to pick numbers in each interval. So I will put pick -4 here. Between -3 and 1, my favorite number of 0. Between 1 and 5, my favorite number, well, I have a 2, 3, or 4 would work, so let's use 2. Beyond 5, how about 6? So there's a lot to check here. I want to see, is it less than 0 when I plug those numbers in? So I'm going to use my graphing calculator to help me with that process. Okay, so plug -4 into this and see what you get. But again, I'm going to let the graphing calculator help me with that process. So go to y equals, and we'll type in x cubed minus 3x squared, minus button is here, 3x button is here, x cubed minus 3x squared minus 13x plus 15. And I am interested if my test points are less than 0. If I plug my test point in and I get a number less than or equal to 0, then it wins. So again, I'm going to go to second table set, make sure it's on ask, which it is. If it's not on ask, you can move it. This is how you switch it. That's how it goes from ask to auto, auto to ask. Go to second table and then plug in our test numbers. So my first test number was -4. Is the result less than 0? I get -45. So when I plug -4 into that, I receive -45, which is less than or equal to 0. So that's true. That's yes. So I'm going to shade this way. Okay. If I plug 0 in, 0 cubed minus 3 times 0 squared minus 13 times 0 plus 15 is just 15. Is 15 less than or equal to 0? That's no. I will convince you of that by showing you that on the graphing calculator. Plugging in 0, indeed I get 15, that's no. I want to plug in 2. I'm interested, is it less than 0? I get -15. Plugging in 2, I get -15, which is less than or equal to 0, so I'm going to shade there. Then I've got to plug in 6. When I plug in 6, what's the result? 45 again. Notice the symmetry of the numbers is always kind of interesting. 45. The question is, was that less than or equal to 0? Again, that's no. So I'm not shading here. I'm not shading here. So if I put the intervals together, the result will be -infinity to -3 square bracket union square bracket 1, 2, 5 square bracket. So there's a lot going on here. I want to take one quick look at the original thing, well, not the original, but my second line. I'm going to look at the graph and see if the graph supports this idea. So I'm going to graph this, which is already in my graphing calculator. X cubed minus 3x squared minus 13x plus 15. Is it less than or equal to 0? Where is that below the x-axis? So let's take a look. So if I do zoom standard first, and I assume I'm going to, again, need more y to get a feel for this graph. Here's my zoom standard. And it goes a lot way up, it goes a lot way down. So yeah, I need a whole lot more y. So I don't know, I'd like to maybe double or triple the max on y. Maybe I'll triple it. Maybe I'll quadruple the y min. Let's see if that's a decent graph. Well, I'm lucky today. Things are working. So remember what the question asked. It asked us, when is this function less than or equal to 0? It's less than or equal to 0 from here beyond. So that's from -infinity to -3 when it hits 0. It is not less than 0 here. It is less than 0 here, which is from what to what? From 1 to 5. And then it's not less than 0 beyond 5. So that reinforces what we did here with our algebraic strategy, that this thing was less than or equal to 0, negative infinity to negative 3, square bracket, because less than or equal to, union square bracket, same reason, 1 comma 5 square bracket, less equal to.